This is the fifth and final video in the binomial real options pricing model exercise. If you have not completed videos 1 through 4, you need to stop this video, go and complete those videos so that you have a worksheet that looks like this, that the state model has been set up. Now to move forward, we're going to need to solve for Q sub U, or the state up condition. We're going to calculate the binomial model pricing. We'll put that formula in there. It won't show an accurate answer yet, but we need it in there. We need to have all of our formulas in place in order for Solver to be able to find that state up condition, that Q sub U value. To calculate the binomial real option model price for this project, we need to take our net cash flows, multiply them times the corresponding state prices, and add them together. Now you could spend hours writing a formula to do this, making dozens of mistakes, or you can very simply use the sum product function. That's what we're going to do. We're going to take the sum product of, and I'm going to put my cursor here, and don't worry that I'm putting it on a word. Sum product will ignore non-numeric values. I'm going to select my entire net cash flow. Careful not to get the timeline down here. I need to make sure that this array corresponds with the next array, which is going to be comma, my array 2, which I'll start at state prices here. I'll click and hold and drag and get them all. Release. I need to make sure that these two arrays match in size, otherwise sum product will give me an error. All right, that gives me sum product. Now that value is not correct yet. Now we're going to need to, what we want to do is set these two models equal. We want net present value and the binomial models to be equal. So in this cell, we're going to calculate the difference between net present value and binomial. So we'll take equals the net present value model, which we calculated in the previous exercise, and we'll subtract that from the binomial model, which we're in the process of counting now. All right. Now what we want to do is set this value to 0 so that the two models are the same. So we'll go ahead and click on our Data tab, and that will move us to Solver. If you don't see Solver here, you need to click on File, select Options down here. Then from the options, you need to select Add-ins right here. See Add-ins at the bottom, Manage Excel Add-ins, click Go. And you'll see that you have a few things. If none of these are checked for the purposes of this class, it might be a good idea for you to go ahead and check Analysis Tool Pack, the Analysis Tool Pack for VBA, and certainly for this exercise, the Solver add-in. Once you've done that, select OK, and Solver add-in will appear up here. I'll just cancel since I already have it. And that, now I'm back to my exercise. So I'll select Data and then invoke Solver. Move it off to the side a little bit. I'll take some of these values out since I've solved this. I don't want to confuse you. I want it to look like the way yours might have come up. So first of all, I want to set my objective function, which is here. I want to set this to a value of 0. And I want to do that by changing the upstate here. This entire model is set so that when we calculate the upstate, it will solve the problem or bring us to the next to the last step of solving the problem. Two other things to make sure of. ensure that the make unconstrained variables non-negative is checked. That must be checked. And ensure that GRG nonlinear is selected as the solving method. Then go ahead and click Solve. You'll want to say OK. And there you go. You found the value of the Q up, the state up, that makes the model 0. The model works. Now, we need to see if this project is worth doing using the binomial real options pricing method. We've used the NPV method and we found that it's got a minus $268 value. So we want to use the binomial method now to solve it. Our next step, what we want to do is preserve this that we've done for future use. So I'm going to copy this tab. I'm going to right click on this tab and I'm going to select Move or Copy. I'm going to go down here and click Create a Copy. That's important. Click Create a Copy. I'll move it to the end and say OK. So it creates a copy and moves it to the end. Now I'm going to double click on the state 2 and I'm going to change that to real. This will be our real options pricing model result. Right now I have to do a few things. Now I'm going to leave these values. These are all set. These are fixed values. That's the great thing about Solver. It doesn't put a formula in here. It puts a real value in here, a real robust value. You want to leave that there. But what we need to do now is take away the negative states. We would have abandoned the project in any of these negative conditions. By leaving them here, they're influencing the costing of our model. They're not real. We wouldn't have continued through these periods losing this kind of money. We would have stopped, or at least that would be our plan. So I'm going to take them out, just delete them. Delete, 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 delete. Now I need to go down here then and delete the corresponding sections. And be sure not to delete any extra sections. Just you see this one's gone, so we're going to delete it. And this last one here, all of the down states are gone. Right? And in the last two periods, these two states are gone. That one in period 6 and this one in period 7, so they're gone. Now we have one more adjustment to make before we can get to the cost according to our binomial system, or binomial model. We have affected our binomial coefficients. We don't have n choose k number of ways to reach each of these states in the middle because we've eliminated some of the paths to these options. So we can still get to this option this way, but we can no longer get to this option this way. And it's the same for all of the options along this row. We have taken off this path. So you can still get to these options like this, but you can no longer get to the option by that additional down state and then getting to them. So they've all lost one opportunity, one path to them. So we need to take that off of the combin statement. What we're going to do then, I'll start here in period 5, that down state, and I'll put the combin in parentheses. It's going to return a value, and I want to reduce the value it returns by 1 because that combination doesn't exist. One less combination. Same way here. I'm going to go up here and put this in parentheses. It's going to return a value, a number of combinations, but now there's one less combination, so I'll take that away. The same here. Put this in parentheses, take 1 from the number of combinations, it returns to indicate the elimination of that negative state. Now, this, we've removed two paths to it. We used to be able to get to it by going down to here and over, and we used to be able to get to it by going these up states to here, down and over. We can't do that anymore. These two paths to this value have been eliminated. So we need to reduce that combin value. It returns the number of combinations by 2. And when we do that, our model is complete. And we can see, let's zoom in here, that our net present value model priced this project at a negative $268. So we would have declined the project. However, our binomial real option pricing model prices this project at $25. That's a positive amount, and if it meets our hurdle rate, if it meets the criteria for project selection in our entity, it's certainly going to return a positive cash flow. So it's a project we might want to consider. We're no longer going to reject it as a losing proposition. That completes the binomial real options model pricing exercise.